All right. Hello and welcome to the virtual Kansas City SQL Server user group. Thanks for joining our Lunch and Learn AI edition. Today we have Lewis Prince presenting model creation in Azure AutoML and ingestion through Excel. So hold back all your VA people. They're going to love it. For our US folks, this may be a lunch and learn, but don't feel left out if you are joining us from somewhere else. Feel free to eat, snack, or just sit back and relax and learn along with us. For the audience, the session is recorded and monitored by the powers that be and will be uploaded to our YouTube channel. Questions will be monitored throughout and asked. And as usual, with our Lunch and Learn, we jump right in. And with that, I'm going to let you take it away, Lewis.
Thank you. As just said, I'm Lewis Prince, and I'm going to be talking to you today about model creation in Azure AutoML and ingestion through Excel. So, a bit more about me. Next slide to go on. In terms of who I am, I work as an AI engineer for a company called Frog Systems. We're based in the UK, around about the middle, called the Midlands, near Birmingham, the second biggest city over here. In terms of my credentials, I'm a certified Microsoft data scientist, an AI engineer associate, as well as of the last year, a Microsoft AI VP. So I'm quite well versed in AI and data science applications, and specifically so with the Microsoft stack. And in terms of general experience, I've been in the data industry about 7 years now, working primarily through R, VBA, SQL, Spark, Python as languages. And I also blog in my spare time under the pseudonym of the Data Rhino, and that QR code there will take you to my blog site, or if you just want to type in the web address, it's as described there. You'll notice I haven't got a direct domain. It's still .wordpress.com because I'm a bit too cheap to pay for the domain myself, so I'm keeping it as free as possible at the moment, just to host kind of my mutterings and more extensions of the talks I do. You'll find those blog posts. So let's move on, talk about me, and talk about how we're going to get this session across to you guys. So first of all, I'll have a couple of slides on what machine learning is, where we'll define that baseline knowledge and get everyone on the same footing. And then we'll move on to what AutoML is. We'll discuss who should be using AutoML, whether it's not just for beginners in getting into machine learning, but also experienced users like myself make use of AutoML a lot, and we'll get onto those reasons later on. I'll then discuss what problems can we solve using AutoML. Problems in machine learning kind of refer to the jobs we can put through AutoML and be automated by that service. I'll then have a brief talk on metrics. These will be metrics for classification problems and regression problems. Two words we'll define later on. It's something I've added quite recently into this talk, following on feedback in terms of people can do the AutoML, but posing that question of whether we should be just trusting what comes out. So I decided to add this bit on metrics to equip yourselves, so when AutoML kind of creates these models for you and gives you these models, you can go in and question critically whether the models that AutoML is making for you are fit for purpose, are doing what you want them to do. So give me that toolkit to kind of question AI and not just be biased with automation and just go along and accept what it's saying. Yeah, and then questions at the end. So I'll leave about 5 minutes at the end for kind of wrap-up questions, and I'll have some questions myself for you, just to clarify knowledge as we go along. There'll also be demos today. The first here, where I will be walking you through the Azure ML Studio, and that's where AutoML is held, along with a lot of other AI capabilities in the Microsoft stack. And then after talking about problems we can solve, I will demo how we can get data into the AI Studio, how we can then put that into an AutoML workflow, get jobs out of that, register our models, and then expose our models to an endpoint. And then the final demo, we will use that endpoint to generate new data in Microsoft Excel. So, and those to the right there are our learning points. Sorry. So they will pertain to what I hope you guys get from the session today. And also, if you have no questions at the end, I'll ask you these questions in terms of getting you to tell me what you think machine learning is based on what I've said. Tell me how we can use the model to create spoilers. You'd use them in Microsoft Excel. So here we go. What is machine learning? So if I was to go to the Oxford English Dictionary, I don't know what dictionary you would have over here, but that's the dictionary on most people's shelves over here in the UK. It would give me a definition like so on the screen. Study of computer algorithms that can improve automatically for experience and using data. But what does that really mean? And what machine learning is, it's a branch of AI that we're teaching computers to learn off of passive data. So data of stuff that's already happened. So for example, if I wanted to get a machine learning model which could predict loans, rejections and approvals, I would go away and get a lot of passive data on that. So data based on people who've been approved or rejected for loans, along with supplementary data the bank might have when making these decisions. And then I would feed it into a machine learning model, and then use that model, I predictions in the future on unseen data. So new data, new customers come in for that model to then make these decisions based on what it has seen from that passive data I fed into it. So if we were going to look at this pictorially, what we said there, we would get passive data, so the information on loan rejections and approvals that a bank may have. We would give that to a machine learning model, and these models work in very different ways depending on what you're using in terms of how they decide how a decision is made for how someone's balance and credit score, and the number of products they have, and the amount of time they've been with a bank, how that equates to an approval or rejection. So the model sees patterns and analyzes the data to create a platform, a framework for its own decisions to be made, and then it applies that framework to new data given to it to then give us answers and speed up processes in getting those answers and being unbiased in doing so. So now we've established what machine learning is, it's kind of pertinent to me to then discuss how we can do machine learning. So the usual workflow goes as such. Usually a question is asked, a question is posed, and it's quite important at this stage, and it's quite pertinent to the success of overall project of how good a model will be. It is making sure this question is specific, and what you're asking, the answer we get is to answer that specific question. So for example, a client comes to me and asks, I want a model which will predict my sales for a new store or the sales I'm going to make next week. My answer would be, what do you mean by sales? You want about how improving that in terms of how many products you sell, how many units you're moving, how much profit you make. So a question being asked is an important stage in making sure we are very specific in what that question will be. Then we move on to scanning the data that a customer may have or we may have to see if we have enough data there or the right data there to answer that question. And once we establish we do, or we haven't, we've gone away and got that data in, we can move to the next stage. It's where we generate features. Feature generation is quite a big part of the ML process as well. It's where we get a lot of the value from an ML model. It is how good we do in generating features and how well we do in terms of making sure we're generating good data and getting the most out of the data we have to feed into the model. Because the model will only be as good as the data we put in. Bad stuff in, bad stuff out, for example, without using expletives. And once we generate these features, we then go into pre-processing. And this can be such things as filling in NAs, normalizing data, categorizing data. So to explain those last 2 points, normalizing would be when we set information which is on a continuous scale, like someone's balance or their credit score, and we put them all on the identical scale of 0 to 1, for example. And why that happens is, we say for the credit score, a difference could be in the hundreds, so a difference of 200 600 for a credit score. But someone's balance between two customers could vary by hundreds of thousands of pounds or dollars. And ML models work on these magnitudes, but really they shouldn't, just because balance is in a higher denomination, it shouldn't have more of a bearing in terms of the magnitude of change over credit score. So we do stuff like pre-processing to try and alleviate those problems and to make the most of the data we have and to make it as readable as possible from an ML model. So once pre-processing is done, we experiment with algorithms. I said earlier, each ML model algorithm works in different ways and have their own weaknesses and strengths. So if we're doing ML manually, the process is very much so we get our data and we create many models with many different algorithms that we think will work well with data to find out what is the most effective and what algorithms going to give us a model which will give us the most benefit, will answer the question we're asking in the best way, in the most accurate way. So once we've done that, we'll test the final model. And we may find, once we test this model, it's not fit for purpose. And we might go back for this whole middle bit again and again and again to generate new features, try new things. And it can be a very iterative process to do this work, get to the final model and find it's not fit for purpose. So this is the chunk where a lot of the time, as a machine learning engineer, an AI engineer, someone working with machine learning models, will spend that time going through this process, iterating and fine-tuning the different steps in this process. But once we are happy with our final model, we'll put that model into production, and then we'll go away and continuously test that model. So just because it works now, it may not be fit for purpose in a year's time. And just with the change in the change of data, the change of influences in the market, the expectation for what a bank wants someone to be approved or rejected for a loan may change from now till then. They may want to have more people having loans in the future. So the attitude towards approvals and rejections may change, and state of data may change. That's why we have to continue to test and make sure that the model we have in production is still doing the job we designed it to do, and it's still answering the question originally asked in the correct way. So make sure there's no questions yet. Yeah, cool. I suppose can you thumbs up still to make sure everyone's still along with this and it's going well? I'm looking over here.
Yep, going great.
My chat screen. It's going good. Okay. So we've established the machine learning process here, and we'll move on to now what AutoML is, and then a subsequent slide on what part of this process is AutoML doing for us and speeding up for us. So what is AutoML? It might be a pretty stupid question, because I'm going to tell you now, it's automated machine learning. It's what it stands for. Much like ChatGPT and Copilot are automating report writing, transcribe meetings for us, AutoML helps us create models. It does model creation for us given data. For me, really, all that means it's a time-saving tool. And we get to the next slide, I'll show you. It's automating the most time-consuming part of the machine learning development cycle. That bit in the middle we'll speak about, where we can go over and over and over. But in particular, it does those two middle sections in terms of pre-processing and experiment algorithms. How it does this, it'll go through, and with those pre-processing and algorithm options we have, it'll go through many different combinations of the two, assessing via a key metric that we decide in terms of what success looks like when it's going along, and it will keep improving as it goes along. So once it finds a model combination that's better than most, it'll go into there and mess around with the pre-processing and the hyperparameters. Hyperparameters being for the algorithm, the bits you can change on input. So for something like, I might get too technical here, a random forest, which is decision tree based, it's the trees in there and how far it prunes, it goes down through that decision tree before it stops and moves on to another decision tree. So you'll mess around with all these things and all these little knobs that me, as an ML guy, an AI guy, it would take a long time to go through and try all these different combinations manually. So I would come in as an AI engineer and do these bits from the start. So asking the question, make sure it's good, scan the data, generate features, and then I would pass this off to AutoML to go do that really iterative process for me of experimenting with pre-processing and experimenting with different algos, and then getting the model out for them and seeing, is that model good enough? Is it doing what I want it to do? So yeah, that's the bit AutoML does for us. And that's what it does. So let's, without further ado, move through a demo of the Azure ML Studio. My mouse find it there. So here we have the Azure ML Studio. It's been going for quite a long time now. Even in the time I've been working in INML, it has had a lot incorporated. Even this new generative AI prompt flow window you see in front of you, that's only been there for about 8-9 months, maybe a year at a push. I remember it's not the best, but this is what you come to when you open up the ML Studio. And you'll see instantly off the bat, there's stuff that can get you started if you're new to the ML kind of space, to get into dipping your toes in the water. So you have these notebook samples, and they will mostly be in language such as Python or C#, Java or TypeScript, that can help you start training and deploying a model yourself. Or stuff at the bottom, which we'll go into in a bit later in terms of creating notebooks and creating computes which run your notebooks for you, training models, deploying models. So I'll go through now these tabs on the left in terms of the ones I think would be most useful for yourselves. Kind of go through what's available here for us to look at. So this first one here, notebooks, and this is where we can put stuff like little bits of code to go and get us endpoints and to do fancy stuff for us. Again, it's usually in Python, JSON, TypeScript, the usual languages Microsoft likes to use and see. And then we can have stuff like AutoML. So this is where AutoML sits, and we'll come back to this in the next demo in terms of how we can go in here, create our jobs, and go through that wizard to kick off an AutoML job. And then we have Designer. Designer is what the first instance of Azure ML Studio was. Let's click on open if we can. It's quick enough. And it probably is quite a nice way of into more advanced ML AI workflows. And it is this kind of click and drag components So it's something else if you want to experiment, it might be a good place to get started. And there are shortcuts on that home screen, which will take you through and give you pre-made models of these and give you hints and tips on how to get ahead and doing designer stuff. And then onto the assets sub-ribbon. And this is probably the most important for what we're doing today, but for anyone using the Azure ML Studio. The first is data, and this is where we can create and store our data. So it's broken into data assets. So these are individual data sets, data stores. This is where we store our data. Usually blob store, databases, files, and then dataset monitors. These are, without going into too much detail, ways that we can check. And I said earlier, models can go out of date when we put them into production, but that can be prompted by data drifts, where data sets, the production data that we see in a year's time, is different to the data we trained our model on. And that's what data drift is, when the production data is different to what we trained on. And this is what can be used to automatically get triggers for when we think the model data is vastly different to what's production, and could prompt a retraining. It could prompt us to go into that machine learning lifecycle again. So then jobs are the outputs of AutoML notebook runs. So this is where we get summaries of the work that's done by us in the AutoML studio, the Azure ML Studio, or done by AutoML in the studio. We have components. There are kind of bits where you can save building blocks for tasks, building blocks of the designer kind of workflows of your Python scripts. So this is a way you can create reusable things. Pipelines, these are exactly the same designer. So what you make in designer are pipelines. So I won't open that up again. Environments, these are useful for when we deploy our models. And what these are collections of kind of Python scripts, what operating system is needed for the model, what version of Python is needed to run the model, what version of Java is needed to run the model. So these are environments that are pushed out into the containers that our models are in. And through the AutoML, this is done automatically for you, so we don't have to worry about it too much. And then models, this is where our models sit. This is our model for today. We'll look at that in the next demo again. And then endpoints, once we get our models and we push them up, this is where our deployments sit. And then going on to compute, this is where the brains of the operation sits. So the workhorse of the ML Studio, you create these yourself. And they're what's used to either run AutoML for your notebooks, but you can also use them as the workhorse behind your endpoints. Probably not best practice to do so. It's probably better to have two separate ones. But for this use case and this demo, I've just used the one Lewis free to do the work for us. So that is the whistle-stop tour of the ML Studio. And let's go back to the slides, and we'll carry on with in terms of what AutoML can do for us, who should be using it, and what problems can it solve. So here we go. So who should be using AutoML? And I alluded to this a bit earlier in terms of the appropriateness of it being usable for everyone and anyone. So for beginners, newbies, what does it give you? It gives you a great access point. So through the AutoML kind of option earlier, and the whole GUI interface I showed you in terms of getting data in, creating our endpoints and chucking them out, there's no to relatively low code or ML knowledge needed to make use of AutoML. Now I say relatively low coding because there is a bit in the back of the Excel spreadsheet that I'll show you later on in VBA to make that call up to our endpoint, because essentially it's an API, and then get the data back and push it into the Excel spreadsheet where we run a macro. But that's not entirely necessary. Most time, Microsoft does give us code either in the main four languages again, Python, Java, C Sharp, TypeScript, Java, sorry, C Sharp, Java. So a lot of the time, the heavy lifting in terms of writing code is done for you by Microsoft, and you copy and paste it in. So I'm pretty happy saying no, and relatively low coding around my knowledge, you can get by. It's also a learning tool. So I'll show you later on when we get to the models. But you can see under the hood, you can see the Python, the Java, whatever coding language is used, and your preferences was used to do the experimentation of AutoML and to create the models we're using. So if you're willing to go in and put the hard graft in, you can get that code, look at it and read, use it yourself, make adjustments, and experiment it on your own terms. It's certainly how I have learned bits and pieces of the process when I started all that time ago. So yeah, a very useful tool to have. And the biggest thing of all, it allows you access to ML solutions for all. So anyone can go in really, if they've got a data set that is reliable and trustworthy and it's well cleaned, and use it and get an ML model which you can use just like I'm going to show in Excel later on. But apart from people that are new to ML, more experienced users like myself find AutoML extremely useful. The first being it's a massive time saver, and I've probably said it 3 or 4 times now. AutoML saves so much time in terms of iterating through what is really not a technical piece in the ML workflow. It's picking different models, different pre-processing options in the code. If I was doing it code-wise, so instead of doing a random forest, I do an LG gradient boosting algorithm. I can't remember the pseudonym now, but a different type of model. It's just a case of swapping keywords around in the code and then running it and waiting, seeing the results, writing that down, comparing it, going again, and iterate over and over and over. So it's, and I can't stress it, I'm going to say it again, it is a massive time saver in terms of getting a model out there, in terms of getting a project delivered quicker for your clients, and giving you more time to make sure your data is clean, to make sure you've generated the right features. But afterwards, kind of doing the testing, you have a lot more time to make sure your model is fit for purpose and get it into production in the right way, in a repeatable way, in a robust way. You also get introduced to new algorithms. Microsoft are pretty good at this in terms of introducing new models, new algorithms into the back end of AutoML for it to use. So there has been a few cases where I've used AutoML and I've gone, oh, never heard that one before, or I haven't seen that kind of do so well in a long time. So when improvements are made to these models and algos, you can be surprised. And so it can be an eye opener for the more experienced ML user to get up to terms and get up to speed with latest innovations if they haven't had their ear to the ground. And it can also be used purely through code via VS Code extensions. So you may have spotted that earlier on the notebooks. There is a click to click VS Code and run everything in ML Studio via an SDK through Python or one of the other 4 major code languages that Microsoft likes to offer stuff in. And the same for AutoML. You can invoke it via code, via an ML Studio SDK API extension through VS Code. So that makes it very code worthy as well, kind of accessible for the more experienced users. So what problems can it solve for us? And this is where I'm going to find that classification regression words I said earlier in terms of problems. So currently, classification is we're getting AutoML, getting a model to assign labels to something for us. A lot of the time, this is binary, or it can be multi-label. So a binary classification would be, my example from earlier, a yes or a no to a loan. But it could also be assigning risk levels to clients in a bank environment, low, medium, high. So they're all label applications or classification problems. We're trying to give labels to rows of data. Moving on to time series. That can be done in AutoML as well. Time series is a lot more of a mathematical, statistical thing. But in reality, it's pretty machine learning kind of workflow. An example of this is forecast of oil prices. So creating a predictive model based on time series data, so data over time, to then forecast what oil price will be in the next 3 months. Or going back to my sales example earlier, forecasting what my increase in units sold will be in the next 2 months. And that can be varied by regional factors and stuff that we feed into these models. And then regression can also be kind of different to a time series. Subtly, in this example here, instead of feeding in a time series data, a regression model could be predicting store sales just based on standing points in time. So for store sales, say, you know, the dates that you feed in is every one of your stores that you currently have, and the money they've made over the last 3 months in the years previous to this, feeding that into the model, and then giving a new store the same stuff as where it is placed, where the nearest competitors are, the demographics of the location, and get it to predict what those store sales could be in the first 3 months. And then we can also do much more complex things like natural language processing. So the example would be giving the ML model a series of scripts, as well as the label saying, well, for this script, all the words in there is for a romantic film, or this script we're giving you now is Frankenstein, it's a horror film. And then you would be able to give the ML model a random script that it's not seen before, and it should be able to give you the genre. So that's an example of natural language processing. And then computer vision as well. It can be done through AutoML. So giving it a load of pictures of dogs and cats, and then giving it an unseen picture of a dog, it will be able to identify that there's a dog in that image. So the last two really quite novel applications of AutoML. The first three pretty bread and butter, run of the mill, kind of the nitty gritty workload of an AI ML engineer developer. And this will make more sense when we get to the next demo. This next point is the bottom two problems. If we are going to do them with AutoML, if you are going to, they need GPU compute clusters. So the compute cluster I showed you earlier, the Lewis 3, is a CPU-based compute. Not expensive, not as well as doing the calculations that an ML model does as compared to a GPU. GPUs just do the computation in a much more efficient and quicker way, and hence why NVIDIA are getting such a massive boom in their GPU sales in the last 2 years, because AI's kicked off with ChatGPT and Copilot, and GPUs are what's behind that boom. The big companies like Microsoft, Amazon, Google, OpenAI can't get enough of them, because they are the only way you can get this sort of innovation is by using them, because they're much more efficient than CPUs. So yes, there is a limitation on these last two, that you would need to spin up a GPU compute, and that is significantly more expensive. So moving on from that, before we go to the next demo, any questions?
Haven't seen any in the chat.
Okay, I'll move along then. So AutoML in practice. So going back to the studio again, we'll go through the workflow when I come to do a new AutoML project. The first place I'll go is data to get my data in there, and this is our data set for today. So I'll show that first, then I'll show you how you can get data sets in. So when our data's in, this is the usual interface we get, and I'll tell you what version you're on. You can upload multiple versions, and if I had one or two more, I could flick between the two. And I'll tell you when you created it, when you've modified it, what kind of type is it, what dataset type, who created that. If you've got multiple users in there, you can see there's a lot of these kind of nice little things, but the real value is in the Consume and Explore tab. So the Consume tab, I said earlier, Microsoft gives you the code a lot of times to get the work for you, to get your data into these environments. Depending on what you're doing and what SDK you're using, it'll give you the code to get work for you. And moving on to the Explore tab, it gives you a kind of printout of the first 10,000 rows of your data set. So you can see what we're doing. And what this is, it's a data set I got from Microsoft actually for demoing. And it's a list of, and it's probably why I've used the bank example of accepting and rejecting loans so much, is because that's what the demo is really about. So we've got stuff as credit score, geography, how old someone is, how long they've been with the bank, their balance, estimated salary, and then whether they've exited or not. And now this is based on a 1 being that they've rejected a loan, 0 being they've been approved a loan. So we need to keep that in mind later on. And then we also have profile. And this is quite cool in terms of it gives you an outlook of what your data looks like. What's the minimum, maximum credit scores that are in there? What type is that? Is there any missing data? What's the mean? And gives you nice little graphs as well. So really cool for looking and getting a feel of your data. So if I wanted to put a new bit of data in here, I click create. I give it a name. 5. What format is it? It's going to be a table, a file. Is it tabular? I usually upload CSVs, so tabular is the way it goes. And then you pick from these data sources where your data set is. These are your open data sets, are the kind of remade data sets, it says on the tin there, that Microsoft give you to be able to go away and kind of experiment with this. Or you can use your own from Azure storage, your SQL databases, from your local files on your system. And once you've collected them, I'm not going into it now, but you go through your files, collect one, and create, and it'll create that data asset like I've just shown you. So once that's been created, we can go up to AutoML and kick off a job. So to get that going, we click New Automated. We give it a job name. You give it an experiment name. If we're going to do this a couple of times, you can create under an umbrella of something random to say. Give it a description. Always good to do. So when you've come back to this in a year's time, you can come back and see why you've done something. What might be different to other experiments or runs of the same name, just so when you come back, you know all the information about that and you have context in terms of this run. So once that's done, we click next. We select our data set and we select our task type. Now we're trying to apply a label to this, so a 1 or a 0, where we're coming and going. So we click classification. Click next. We click our target column. So what we're trying to predict, which is exited, that is our 1 or a 0, our label. And then the other things I would suggest changing here is under limits, you have experiment timeout. So this is how long your run will run for. I usually put to 30 minutes if I'm trying to get a feel for what models are useful. I could look into later on, but it can go on for hours if it's going through a lot of different and trying to get the most best model you want possible. 30 minutes is usually a good stopper there. And then test data, train test split. So what this is when we do ML, usually we get the data set we're going to feed in, we take 80% of it, and that's what we'll train on, and we'll leave 20% of it unused. That when the model's created, it'll go away and test itself on there to see how actually good it is. There's no real cold hard reason why the 20/80 split's there. It's just a very good happy medium and kind of an industry standard to be used. So we click next again. We select our compute. So we'll go up an instance here, select the Lewis free, and it'll kick itself off when we start this up. But I'll click next again, and you can see and make sure your settings are correct there. And then we click submit training job, and that would go away and spend the next half hour going through all those pre-processing steps and those algorithms.
We have a
So
We have a couple questions. We've got a couple questions that have come in. One, do you have any suggestions for how to decide if we should try to use AutoML versus some LLM to analyze the data so we can ask questions about it?
I suppose it's data protection stuff. So this is very locked down. Depending what LLM you're using, if and how confidential that data is, if you want it out there, depends if you want to upload it to an LLM like ChatGPT or Copilot, and then even license structure depends on the data governance and the data security of what you're putting up there. So that would be my main concerns. If you've got like a ChatGPT Pro license, or you're in Copilot, Copilot for M365, they're both very secure environments, so it might be useful to do that. But it's worthwhile doing so. I suppose it's up to you. I think what I did just in that data screen is comprehensive enough for me to kind of get a feel for my data. But if you want to have a chat with it, by all means, go for it. I think there's plus and minus for both, and I'd probably go for the LLM approach in this modern day. It seems the most intuitive and the easiest way of getting around that. So yeah, that'd be my answer to that.
That's a good segue into the next question. Do we need to worry about running up huge Azure bills while running these models?
No, not really. Depending how complex it is. So these computes, they're charged by the. Why is not giving me a cost there? That's putting in blocks, but usually it's like 35 cents, like 35p per hour for these smaller models. So to create a small, when I say small, that data set's quite large. It's probably a couple of pounds, a couple of dollars to do that training. The real cost will be in when you expose them as an endpoint. That would be where you spend a lot of money, because that's in terms of where you're going to store the model, and then the computes to keep it up there, and to kind of when you query it, the cost of querying, that would be where the real cost comes from.
That's awesome. No, thank you. Last question. Can you bring in data from multiple data sources for a job?
No, just a single data source. So what I would do is do that aggregation beforehand into a data set, and then upload that data set or get it into there before you go to AutoML would be a recommendation. So it's one source in for the model. So do the aggregation beforehand.
Perfect. Thank you.
Okay, cool. Let's notice some time, so I'm gonna go quick. So this is the output of the model I did earlier. And kind of it's kind of the output you see, and you have something called AUC weighted there. It's a kind of metric we'll talk about in a bit. But you can click these models you can get more information, such as metrics. So we'll talk about these in a minute in terms of what these mean. But this is usually the models are there. They're quite good. They're nice. It used to be the fact that we could deploy straight from here as web services and stuff. But currently, at the moment, you have to click register your model first. So that'll give you a little wizard giving it a name, and then the models will appear in here. And this is the model we have, and then we can use the model to an endpoint. So once you register your model and it's here, you click real-time endpoint, you fill this stuff out, you click deploy, and then it will end up in these endpoints here. And this again, you get the test and Q map. So this is where you can test the endpoint. So it gives you a little kind of interface. You can put data in there, click go, and it'll do it for you. And you got consume again, and it gives you all the information you need to go away and programmatically query that endpoint. So that's the end-to-end process of how we can use AutoML. And I'll go back to the slides now to talk about metrics very quickly, and then we'll go to my last slide. So a quick talk about metrics. So we talk about fundamental terms in terms of classification metrics, and we always talk about this in context. So, for example, if we were talking about we wanted to apply labels to people if they are vegetarian or not, a label of vegetarian could be a positive instance, and a label of not vegetarian would be a negative instance. So when we try and apply these labels, if we get a true positive, that means we have predicted a positive instance correctly. So it's when we predict someone's a vegetarian and they are actually vegetarian, that's a true positive. Or a true negative, we predicted someone wasn't a vegetarian and they were not. That's predicting a negative instance correctly, a true negative. Then inversely, we have false positives. This is when we predict someone is a vegetarian and they're not a vegetarian. So we predicted a positive instance incorrectly. And then a false negative, we predicted someone is not vegetarian when really they are. So a false negative. So this makes sense in terms of these classification metrics we'll come across. So the first being accuracy. So how often are our learning models getting its predictions right? So so true positives plus true negatives. So how many times we predicted that someone is vegetarian and we are correct, and predict someone wasn't vegetarian, we're correct over everything. And this comes out as a percentage from 0 to 1, as with all these metrics. And you might think that's pretty much what we want. That's all the information we need in terms of metrics, how good a model is. But it's not true. You also get these next two metrics, which are very useful. Precision, which is how often the machine learning model's positive predictions are correct. So this little equation at the bottom kind of sums it up, and it's the true positives over the true positives plus the false positives. And what this really is how precise are we in applying the vegetarian label. So when a model says this population are vegetarian, what actual percentage of that population should be expected to be vegetarian based on this metric? So if and we had 10 people labeled as vegetarian by our model, we'd expect only 80% of them would be. And then recall, how often a machine learning model correctly identifies all relative positive instances. And what this means is out of all the vegetarians in our prediction class that we're trying to predict, what percentage of them will our model correctly predict? So if we had 10 people, we could feel confident go into it that if we had a recall of 0.88%, that it would get 80% of those. It would label 8% of them, and we'd have 2 that would be incorrectly labeled. So why are these useful? So let's go back to that vegetarian example. If we had 100 people and 5 are vegetarian, there's quite a big skew there. So 95% of the of our data set are not vegetarian. And we want to identify vegetarians. So if we had a model that just predicts not vegetarians for everything, we'd have an accuracy of 0.95, but we'd have a recall of 0 and a precision of 0, because we wouldn't get any of those positive instances correct. And remember, a positive instance is we predict vegetarian, as that was what we wanted to know. So we know something's wrong there. We haven't got a balance in those metrics. But inversely, if we go away and predict everyone's vegetarian, we get an accuracy of 0.05 and a recall of 1 and a precision of 0.05. Again, if I was to get to a model I know is not really doing what we want and it's not answering the question we want, this is why these other metrics are quite useful. When would you use them? Use accuracy when data set is balanced. And that's what the last slide's really showing. We had an imbalanced data set. If we had an even number of vegetarians and non-vegetarians, accuracy would be a lot more effective there. But with imbalanced data sets, recall and precision come into their own to help us out there. So we use recall. We want to reduce the number of false negatives. We don't want to be telling someone they don't have cancer when they do. Quite an extreme example, but it kind of brings home what the point that is. We would optimize recall in that option because we want to capture all the possible positive instances. But in the case for if we want to confirm correctness of a model and keep false positives low, that would be something like video recommendations, where we don't really care if they are into. We show them videos. If we don't show them all the videos they may like that weren't recommended to them, we just want to make sure that they get as many videos they would like in front of them. So hopefully that makes sense. And then we also get something called a confusion matrix. And this is the total number of these true positives, false negatives, and true negatives. And we always want to see a higher level of numbers between this diagonal here, as opposed to these. So hopefully that's equipping us to be really effective and to question the outputs of these AutoML models when we come to them. I do have a section on regression models, but I won't go into that in the time frame we've got. So I'm going to whistle over them. But if we do want to talk them at the end, I can go back if people are interested, because it's a lot more mathy, that bit. Yeah, and we'll go on to the demo at the end. So, for ado, this is a kind of front end that I could put into a bank manager's hands Excel spreadsheet where they've had someone walk in. They can feed in what credit score this person has, where they're from, all the data features we had in our training data set. And then in the background, under this run line, I've got the following VBA. So without going into too much detail, what this is doing is when I click that button, it's going to take that URL and API key that Microsoft gives us. It's going to go away and find out how many rows of data we've put in there. And there's an extract going along row by row, these numbers, put them into a JSON format, which is sent to the API call here. Then we get a JSON back and we get a 0 or a 1 out, our label. So it could be as simple as clicking that run line. And what that's done is use the model we've created. It's gone away, given these features, and said for these two, we'd accept that. And for this one here, we'd reject. Yeah. So hopefully that's really driven home how easy this can be in terms of taking data, creating a model, push to the endpoint, and using it in a product such as Microsoft Excel, which I know it doesn't get as glamorized in modern day, but it's still a workhorse, and it's still used by so many people in so many industries. I think it's quite important to know that you can still do ML. You can use ML models in Excel, if you know a bit of VBA, which is a bit outdated at the moment. But the code is out there. So to wrap up, I will go back to my slides again. And if there isn't any more questions, I've got some questions for you.
We did have another question come in. Raj says he comes from a Java background. Can we pass variables, which type of algorithm to use, and get results based on that algorithm to the REST endpoint?
So I've never used it in Java. I know from Python you can tell it to do that. So I'm going to presume you can do it if you're using it via code, the AutoML. Through the GUI, it's a kind of clicking what algorithms you don't want to use or selecting what algorithms you do want to use. Programmatically, you can pass variables in Python, and I would be alarmed if that functionality wasn't in Java as well. So there'll be documentation in terms of how to use Java to access that AutoML kind of SDK. So it'd be definitely somewhere on the Microsoft where to pass those variables to and how to use the SDK to do that.
Yeah, and I'm not sure he was asking specific to Java, just that he was from a Java background and was that capability there. So
okay, yeah, the capability there. Yeah.
Excellent. Are there any requirements like regular people going in need to be aware of with AutoML, like settings in Azure or anything? Do they have to ask their admin, hey, can you go flip this switch for me, or kind of?
So the ML Studio is a resource. So if you need your Azure admin to spin up resources for you and give you access to that resource, that would be the requirement. You don't pay for that resource to be up. You pay for the compute under the hood. So that would be the only thing you think about is when you spin these computes up, make sure they're turned off when you're not using them. Make sure you're monitoring what you're doing. So you're not running it for overnight or for 4 or 5 days, because that can run up big costs. But that's the same as using a SQL pool or anything in Synapse Analytics as well. Just using the monitoring that's available to you to make sure you're not running up a lot of costs.
Excellent. Well, thank you very much, Lewis. I don't see any more questions in the chat, but I know this is going to be great. I have a feeling we're going to get a lot of things on the YouTube for this one, because we tend to, when you mix like a lot of the older technologies with the newer technologies, because you're exactly right. People are using it. So how can I do it?
Yeah.
So
When I originally made this talk, it was for a retailer over in the UK. They wanted to predict new store sales, and their CTO, CFO at the time, his vision was that he'd be able to sit there at his desk at a laptop and just put numbers in and click a button, it'll go away. But he wanted it in a format that was kind of usable for him. He's used to, and as I certainly know, I used to work in finance. The whole finance sector industry, I'm presuming the same in America, is held up by Excel spreadsheets. So it's very familiar to the finance industry. So that's why it kind of became a requirement that I got it usable, and that's why I kind of learned enough VBA to be able to get those endpoints to communicate via Excel.
Excellent. Yep, we still use it a lot, all over finance, healthcare, lots of things. Actuaries use it all the time. They put their formulas in, they don't want to do it again somewhere else.
I used to work with actuaries back in the day, and it used to be my biggest annoyance. I'd make them really nice kind of web apps, and they'd go away and they'd pull the data down into Excel and send me back spreadsheets. I'm like, oh, I can use something really good to use it.
I had to design a system where I took the actuaries' Excel spreadsheets, went into the formulas, and I had to transform it into SQL code for stored procedures. So it's a click this cell and then go over to here, then pull up the VBA and then go there, and
I suppose running out of time. I suppose people want to finish their lunches, and it's nearly bedtime for me over here. But if you
Oh,
guys
yeah,
wanted
yeah.
to get in touch with me, I'll be on LinkedIn. I'm always very free to answer questions there. Go through Christina. She contacted me as well. Go look at my frog blog. Yeah, I'm very open to talking about AI. I'm very open to talking about what I'm passionate about. So yeah, very happy to talk more.
Wonderful, wonderful. And again, thank you so much for presenting for us today. And
Thank you for asking me. Thank you very much.
yeah, had a great time. Thanks.
Okay, thank you everyone. Hope you all have a good rest of the day over in the States.
Yeah.
Thank you.
Hope you have a good night's sleep as well.
Yeah, hope so. Thank you very
Thanks.
much. Bye everyone.